Bismillahirrahmanirrahim. Assalamualaikum, BS 5th semester. Alhamdulillah, we are back and not locally or in a way that you are more familiar with, but we are still back and it's an online system. And you'll be able to see on your screen that you are enrolled to the Applied Chemistry CHEM-121. So, yes, once again, welcome back. Alhamdulillah, the LMS system has been uh, put in place by the commendable IT team and the good efforts and the leadership of a vice chancellor and all the QEC and everybody is such a good effort. I'm a huge believer that opportunities come when things go west. So that's what happened. Uh, online education was not a normal norm for everybody here in Pakistan, but it is coming back. It's getting uh, it's getting introduced to, and it will be hugely beneficial for all the students, faculty members, and in general for the education sector in Pakistan. So, beside the general discussion, today I want to discuss with you the uh, the previously what we have discussed so far, and most important to give you the overview of the course that I have designed for you, the online one for the Applied Chemistry CHEM-121. Before I move on, I really hope that all of you are safe and sound, and so are your families. So, all right, class. When you will be coming on to when you're coming onto your LMS online course for the applied chemistry, this is presently what you will be seeing. Let me just pull out the no setting. That will be your interface that you'll be seeing. So the first one that I have got is a notice board for you, and here we will be having the more important testing, assignment notices, some deadlines, and anything. But yes, I have put out a welcome note for you all that is welcome back to school. Online school is still a school. I hope you all read that, and I have given some background and also a motivational meme that says the great things never came from comfort zones. So yes, you are out from your comfort zone. Online learning, online course may sound quite uncomfortable, not you're necessarily very familiar with it, but I am certainly hoping that it could be something really, really productive and beneficial for your uh, learning and knowledge in general. So afterwards, the notice board, that was the welcome note, which I also said before, but yeah, that was something I put out for you. I had to call it, say it as well. Anyway, so the first section that you have, it will be the course outline, the lecture plan, and the progress. And I have embedded the PDF file for you so that we can track that what's been so done so far. And well, this is a crazy time, so crazy dates, and I've also put out that when we started and then the lockdown happened, and when we had spent 15 days on Zoom, how we had taken care of the oxalic acid and formic acid like lectures, and then inshallah when the HEC will allow and the university, our nation will be back on track for the learning and opening all the uh, getting back towards the normal education and life. We will be getting back to the lectures, but we are preparing these for you. So the course content is there. You all have that with your in your hard copies, and this is what actually I wanted to discuss. That we have the detail of the course plan, what we have done so far to the mids. Your mids are done. You have seen your exams, um, and we have done so far. We have also taken care of oxalic acid. Inshallah ta'ala, from your LMS, you will be taking care of the final term content. We will be taking care of caustic soda and washing soda, polymer industry, textile industry. I had planned that I will take you to a trip for a for industry, but I think this is not the time that I can keep my promise for that. But inshallah, I will find a way that I can put out a 360 virtual trip for you in some way. I recently got the chance to visit various universities online from the 360 virtual tour. It's an amazing feature to really see things from really seven oceans apart. But it is possible, so why not? We can try that for us. um, that's the time of the need, the innovative, or the we have to think out of box here. Anyways, so this is our plan for this. And before I get starting, before you get to the discussions with the polymer and the textile and the cement industry, I also want to give you the backup what we have done so far. All right, so this is where we were in the lecture 1 to 6 in our traditional. It's more like a memory, but here it is. So what we had done was that we had an in-depth look into the applied and industrial chemistry, its causes related to it, the factor related to it, the future, the past, and all the perspectives related to that, and how various basic principles and parameters are practiced, observed, and taken care of uh, during uh, during the industrial processes. Well, it was pretty interesting because you people had given a great feedback. It was amazing classroom experience, and you people had given in-depth presentations later on with your small short projects. So I'm gonna go into that. Into the presentation PDFs we had. I'm just gonna go quickly over that, quickly over to it. So we are we know we are on the same page. So this was mostly I had denoted as a lecture 3 because our lecture 1 and lecture 2 were morely the descriptions and the overall overview of the excuse me, the overview of how the industrial setups and industrial sectors in Pakistan are taken care of. We had also taken an outlook over the industrial sectors and how different sectors are being monitored or regulated by the Board of Commerce in Pakistan. Moreover, moving on. So we had a good understanding towards, let's see if I can put a fit to the screen to that. And yes, I can do that. So we had taken a good look into how to introduce you people were introduced to industrial chemistry, various, and we were able to look into what are the different modes that we use, the different tools that we use to study the industrial chemistry. So you all know that's the branch of chemistry which applies physical and the chemical procedures towards transformation of natural raw materials and their derivatives to products that are of benefit to humanity. Well, not coming to the nuclear plant for the weaponry, but in general, industrial chemistry has revolutionized how the chemical and the physical processes were taken to place, and how something very small on a lab scale can be optimized from few grams to million trillions of tons. You all know, we have studied the sulfuric acid, that its worldwide consumption back in 2012 was reported from 93 trillion tons. It is amazing, but it's done. It's being made, and humanity has to thank chemistry and definitely the physical parameters, the plant physical infrastructure for that. Anyway, so when we looked into that, I just want to take a small note on the idea that where industrial chemistry has been putting its role into. We all know it's food production, health and hygiene. Health and hygiene comes in this present pandemic. It's a perfect example that how the face masks, the vaccines, the drugs were only able to be sufficiently provided, even only if it was for the industries. No men based or hand based procedures could have compensated the present need. But anyway, the shelter production, the aesthetics, decorations, recreation, entertainment, everywhere you go, industrial chemistry has its role to play. We had taken a look into the classification related to manufacturing, agriculture, energy, transport, communication, education, tourism, and all of those are the various industries of the classification. We actually had looked into where chemistry has its role to play. It's the manufacturing, it's the agriculture, it's the energy, and the manufacturing is further divided into the mechanical manufacturing and the chemical manufacturing. You all know that, but I'm just I'm zipping through this quite quickly so we know. Yeah, and there were the two types of classification when it comes to the industry. There's the light and the a heavy industry. So moving on, we had looked into the manufacturing subsectors. So we are mostly, we are actually in our course, we have looked into majority of those. We have looked into the food beverages, to the sugar industry, textile, via various you had presented in your short projects, paper product. It was also one of those chemical, petroleum, rubber, and plastic products. We are onto that as well. And non-metallic, for that we have looked into the acids, both are the inorganic based uh, acids, including sulfuric, HCl, and the nitric when they are prepared in the industry. For the basic metal products, machines, and equipments, that's not something that directly come into the hood of our topic or discussion, but the chemicals that are used in all the procedures, industrial parameter, industrial production, which are taken, which are going under the process for the metal production, for the refinement, for the machines etching, the iron of etching, the etching of the iron, the cleaning, the shaping, all of that is somehow a part of the chemical industry as well, but indirectly. So we were able to further describe the chemical industry into two basic branches towards inorganic and inorganic chemical industries, because it's much easier to distribute thousands of chemicals on the basis of their nature, according to their field and the discipline. So what it happens, how we further first subdivided that heavy industrial organic chemistry are related with the petroleum fuels, the polymers, the synthetic materials. Mostly whatever comes from the petroleum is taken under the hood of the heavy industrial organic chemical industries. As for the light organic chemistry, the foods, pharmaceuticals, pigments, paints, pesticides, soaps, cosmetic products. Yes, cosmetics. Girls should be having the yay moment that yeah, the whole industry is devoted to our needs. So, but there it is. Commodity and chemicals are one of those that we are very much familiar. That what I think we had the chance to differentiate between the commodity as well as the non-commodity chemicals. I want to further switch on to the charts that we had discussed previously. Let's move on to that. Just please allow me a minute. Yes, this is the one I want to talk about. So commodities, specialities, and fine chemicals. They all are different types of the chemicals that are being consumed or prepared worldwide. This is basically based on the global market share percentage division. So the commodities are the 80%. So you can imagine when its consumption or its a global market need, the demand is 80%. So that means its supply would be 80% as well, and the supply would make sure that the majority of the chemical industries are manufacturing what? Commodities. That's clear. So moving on to the next one, specialty chemicals at the 18%. That's very comparable to how the chemical industries sector is devoted to the manufacturing of the specialties. Fine chemicals are the 2%. So let's now come to the point. We are only revising it, so just quickly go through it. So the commodity chemicals are the based on those are the chemicals which are required in the bulk. So what really happens is that commodity chemicals are those chemicals or those sectors which produce the raw material. For example, let me give you an example here. So the paper industry, what it does that. So let's suppose the sector of a printing, the printing sector is the subsection of the manufacturing industry that takes paper as its raw material. But where the paper is being made, it's being processed, manufactured in a chemical industry. So that chemical industry would have paper made into bulk, and that would be distributed, or that would go towards a specialized product such as envelopes, A4 size papers, different cardboards. That's the subsection. But the paper would be into the bulk. It's the refinement. It's further processing. It's further uses. That depends on what the specialty sector does with it. But the bulk would be taking care of the the commodity chemicals. So BICs are the basic inorganic chemicals and basic organic chemicals. So coming from the from a more towards a more specific example, the basic inorganic chemicals would include the sulfuric acid, your nitric acid, your HCl, and other than that, there are more like the ammonia, because they are constantly used into the. For example, here's a very amazing relationship that I can comment on that right now. Ammonia is used in the manufacturing of fertilizers. Now you can imagine that ammonia is a BIC, basic inorganic chemical, and its bulk is being used towards the manufacturing, the industrial manufacturing of the urea, the fertilizers, and the different formats of it. Same is with this phosphoric acid, similar to the sulfuric acid and the other ones. For basic organic chemicals, I can give you the example of oxalic acid. So oxalic acid is made in bulk, but it's used widely for the manufacturing, or you can say the formulation of cleansers, bleaches, different products related to home cleaning and domestic cleaning, or the professional cleaning as well. The workplaces, I mean to say by that. So here we have, with the specialty chemicals, what are those? Those are the medicinal chemicals. Now, medicinal chemicals, let's suppose for the synthesis of aspirin, we would require the bulk of the salicylaldehyde. Whereas for the agrochemicals, different pesticides, you would require the starting material or the catalyst, or the different reagents or the different solvents. Those will be coming from the commodities and will be used by the specialty chemicals, including pigments, flavors, and fragrances, cosmetic products, and moreover that. So fine chemicals. Fine chemical is a very peculiar type. So those are very specific chemicals which are only used for very minute quantities, such as specify. Let's suppose there are certain chemicals that are used for the rocket manufacturing, such as the specific fuel of octane. There is a certain percentage, but this is quite specific for that industry, and that is where the fine chemicals would come in. All right, so moving on, and this is the very interesting perception towards it. The raw material for chemical industry. We all say that nature, we are so much dependent on the nature. Why? Even the whole industrial revolution, when the mankind and the man lifestyle had boosted towards modernism and all the luxuries related to it, but still we are so much dependent on the nature for the raw material. For example, for the sulfuric acid, we have the steam, and we require steam, and where does that come from? The water. The boilers boil off the water to produce steam, to turn on the turbines and the engines, and still it's so much dependent for its whole process towards the raw material. Similarly, for the paper, where do we go for? We go towards the nature, for the towards the trees and the cellulose sources to make paper. Similarly, as well as for the specific ground level, for air, the nitrogen and the neon and the argon that we require, these all are taken care from the atmosphere. So you always have to be thankful to Allah Ta'ala for the nature. Here we go. Moving on, I'm quickly going through because we have already looked into it. This was a complete, entirely in-depth course that we had looked into the lithosphere, the raw materials from lithosphere, from the biosphere, and from how it's all being, how much we are dependent for the nature for the industrial processes. Now this one is important because it gives us the idea that, okay, now we have the basic understanding of the industry, how it works, what it really goes on, and then there is the question, okay, so how does the industry work really? When you look in the infrastructure, where is the junction where chemical processes and the mechanical processes are taking place, and what's really happening over there? This juncture is where we learn about the chemical processes and the unit processes. So let's take a quick quick revision towards that as well. So now, what the chemical process is. The typical industrial process can be illustrated in a very straightforward process that we put the input material. Let's say we have ammonia, and then we have the process transformation. Take a quick look, or in a, just a very focused look on the transformation, and then we have the urea as the output product. So what does that mean? It means that during the process there is the role of the unit process as well as the unit operation. Unit operation is the mechanical part of that, and unit process or the chemical process is the chemistry end of it, the reaction, the interaction of the reagents and their percentages and all that. So I will be moving onwards. All right. So yeah. Now what? Okay. Now one of the examples I had quoted before was that the steamer, it boils off the water into the vaporized form that takes that initiates the various mechanical processes. So what is that? One of those that I want to talk are the unit processes. So unit processes are so many chemical processes and the chemical reactions that you have studied in your organic and inorganic. Acylation, you're familiar. Then the introduction of the acyl group, alcoholysis, breakdown via alcohol, alkylation, introduction of the alkyl group, amination, introduction of the amino group, amino analysis, aromatization, dehydration. I just want to take a quick look and use my full screen snip and just kindly write off the acylation process. So here we have. Let's try to use red. It could be a little bit. I am not sure why it's not working for me here today, but okay, let's try to use the whiteboard. I think it has to do with the screen. The screen recorder I have, and that's what it's. Oh, please excuse my whiteboard. It's from our different. Okay, all right, this is working. So let me take the snapshot, a quick of it, so we can have this on. Right, let's go. Okay, so we have the acylation. We are familiar with the acylation group. We have got the acyl group over here. For the alcoholysis, it's the breakdown through the ROH. For the alkylation, it's the introduction of the alkyl group. CH3 is the methyl. The basic one will be the alkyl. Amination is the addition of the ammonia. Ammonolysis is the breakdown via the ammonia, whereas the aromatization is the closure of the ring. Let's suppose if we have this, and we can convert that 1, 2, 3, 4, 5, 6 into a whole procedure. The chemical procedure would be unique and would be quite systematic. I'm just going over for the quick revisions over here. So carboxylation would be addition of the carboxylic group. Causticization would be through the caustic soda addition. Combustion would be the breakdown via the carbon source. Condensation would be one of the examples that you have studied in the organic chemistry. The aldol condensation, it's one of the most common industrial condensation process that you can ever come or can be. All right, so let's get back to it, and here we go. I think for a minute I thought that the recording had stopped. It was quite scary for me. All right. Okay. So moving on, that we have fermentation, through the whether it's enzymatic fermentation or via yeast. It could be hydrogenation, addition of the hydrogen, hydrolysis, breakdown with the water, ion exchange, that is the chloride ion exchange, the fluoride. Fluoride is one of the common used in the toothpaste industry. Isomerization, conversion of one isomer to another neutralization, the reaction of the acid and base towards the synthesis of the salt in the water. Oxidization could be, the one of the most common is the ozonolysis. You're very familiar with the oxalic acid process. Pyrolysis is through the steam, the breakdown, or with the heat. So, all right, let's close it and let's get back to our original website and let's see.